Okay, so in the last lectures, we have covered how to visualize vector data and how to add some functionality to your package. So um, if you haven't watched the video, make sure you do that. Don't skip the video because all the requirements for Lab 6 is all in those videos. I have show you how to do that step by step. So make sure that you go through the videos and feel free to ask questions if you have any. For today, we're going to talk about how to visualize raster data set. So if you're doing anything geospatial, you're probably dealing with either vector data or raster data. So vector data, we cover how to visualize GeoJSON, but you can use GeoPandas to pretty much open any vector data set. For raster data, we don't have that many data formats. So what kind of raster data format you are dealing with? What kind of common raster data format that you've been using? TIFF, right? And for non-geospatial, we have PNG, we have JPEG, we have WebP, some of those formats. But for geospatial, we'll be mostly dealing with GeoTIFF. And anyone know what's the differences between GeoTIFF and cloud-optimized GeoTIFF? Have you heard about cloud-optimized GeoTIFF or COG? C-O-G? No? Good. Then we're going to learn about that, how to visualize some of those. Cloud-optimized GeoTIFF is just a GeoTIFF. So it's still, GeoTIFF is a very flexible and complicated data format. And cloud-optimized GeoTIFF basically is adding some additional information in the GeoTIFF to makes the data accessible through HTTP request. Kind of similar to if you're using any web services, right? You zoom in and zoom out. It's not downloading all the data. It's requesting the data at a certain zoom level and extent. And it's very powerful. I'm going to show you later how we can utilize some of those. But for today, I want to cover how we can use Raster.io to read some raster data, and then how we can use LocalTileServer to visualize data using Python. Okay, and we might not have time to go into every single details, but I'm going to go through that quickly so that at least if you're going to do some manipulation of your raster data, you can do that pretty easily. All right, so but you need to make sure that you install the package. And let me go to my notebook here. Actually, it's under the GOG 550. It's not here yet. So let me go to my 510. And let me make sure it's still up to date. Okay, so I'm going to open Raster.io. Here, it's a relatively long document. We will not have time to cover every single details about using Raster.io. So Raster.io basically is a Python library for dealing with raster data. It's probably the most popular Python package for dealing with geospatial imagery, raster data. And it built on top of the one called GDAL, Geospatial Data Abstraction Library. Have you heard about GDAL? If not, now you know, okay? So this is kind of foundation, is a long history, Geospatial Data Abstraction Library. And that one was initially developed using C and C++. It's a very complicated one. It's a long history. It empowers so many software, especially QGIS and then some type of ArcGIS or even Google Engine. It's a very popular one. It's open source, but it's a little bit difficult to use, especially using Python. So it's a complicated one. You can think about this is Microsoft DOS. Okay, now we're using Microsoft Windows 11 or 10 or 8. But this is like has a long history. It probably has, I think, 20, 30 years now. And it's very, very powerful, but it's difficult to master. Not very easy to use, basically. But Raster.io built on top of that one makes it a little bit easier to use. So if you ever need to deal with raster data, Raster.io probably is the one that is going to encounter. You're going to find a lot of source code examples on the internet. If you're dealing with raster, it's going to use Raster.io one way or the other, most likely. And we also NumPy, GeoPandas, and Matplotlib. So Matplotlib is for doing like plotting. And so for today, I'm just going to quickly show you the example of how you can read the data set and get some metadata information. So I'm going to go here and then select the kernel, go to GeoKernel. So I assume that you have already installed the package. I believe it's already done. Okay, so you import the libraries. Everything is good. So next, let's take a look at this one, how to open the data. So this one right now, I'm pointing to a data set on the internet, but you can also open the data on a local computer. For example, if you click this one, it's open a dialog, allow you to download that one to your computer. So for example, here, I can just save this one to my computer. It should be fine as well. So you can open the data using either way. You can open the data directly through the HTTP URL, or you can also open data from a local computer. So for this one, we're just pointing to this raster file path, and then just use this raster to open, and that's it. So after that, you can print out. This is so-called the dataset reader. And the file is not too big. If you go to the directory where I downloaded the data, so I'm going to go to my, this here, DM90. So this one is like 17 megabyte. So if you want, I can also do it like this, command, not command, copy, and then like this, backslash. If on Windows, make sure you put an R at the beginning, okay? So then the file paths can be handled properly. And right now, if I run this one, you see it's the same. So you can open the data either from your local computer, or you can open the data through HTTP URL. And after that, you will see this one, right? The data set, blah, blah. And after that, you can look at the name, you can look at the mode, you can look at the metadata. So this is essentially some of the basic information you want to know about the data. It's pretty much the same if you go to open the data set in QGIS or ArcGIS. How do you look at the metadata? How do you look at the raster imagery, right? So you can open it and then go to maybe, let me open Google Satellite, and so simply just drag and drop that one here. Zoom to the data layer. That's it, right? So this is the imagery here. So traditionally, if you don't know Python programming, you need to use desktop GIS, and then you're going to look at this, all this information, the extent, the width and height, the data type, the driver, blah, blah. And it's the same, like you can get those things programmatically, okay? So you're going to stay with the driver, it's the geotiff, integer 16, width and height, and also the coordinate information. So it's same thing like what you're getting in here. And for coordinate information, you need to get to this section. It's going to tell you this one is EPSG 3857. So basically the web Mercator projection used by all the web mapping libraries. This is essentially how you're doing that using desktop GIS compared to your doing that using Python without the web interface. And you can look at the coordinate information, right? So the SRC basically is the pointer. So you can open the data and it doesn't load all the data into the memory. It actually just pointing to the data set and then it's requesting the information when it's needed. It's not going to load the data entirely because the data set can be, think about it, it can be several hundred megabytes. It doesn't matter. It will be super quick. Imagine this is the same as you're streaming videos on YouTube, or you are watching Netflix, right? You are watching a high definition movie, but when you open, right, it's instant. But keep in mind, you don't have access to the entire file all at one time. It's based on your timestamp. It's going to basically retrieve that. So the idea is the same as the cloud optimized GeoTIFF. That means the file can be huge, but if you need to visualize a small portion as a based on zoom level, it's just going to request a tiny piece of that. Make sense? So right now, for example, I can maybe show you like in action how it can be really powerful. So I'm going to go to my maybe dataset directory here. Okay, and then somewhere here, releases. And I'm gonna go to maybe the raster dataset. I can show you some examples. So go to the raster here and scroll down. Let me find a big one. For example, this one. Look at this. Lane set 1.2 gigabyte. If you want to download it, you're welcome to click this one. And you're going to download, you're going to take some time, okay? Depends on internet speed. But for me, if I want to inspect this data set, I don't have to download it. All you need, I'm going to come here, right click, copy the link URL, all right? And then come back to here. Replace this with your new URL. The same line of source code. So this is the URL, and I'm going to use Raster.io to open it. And let's see how long it's going to take. 1 second, 2 seconds, maybe. Is it going to be faster than what you downloaded from here? Entire file? I'm sure it's going to take maybe a minute or two. 4 minutes, second left. It's going to take some time. I don't like it. I'm going to cancel it. You get the idea, right? So if you need to read the data, you don't need the entire file. It's basically, this is where so-called cloud optimized GeoTiff, because when you're trying to access the file, in the header, it has some information already in there. Kind of like a notice at the beginning. For example, you're trying to know everything about this building, or you're trying to find somebody, a professor in this building. And there may be a sign, a notice at the door and outside saying that, okay, the professor is in room 309. Okay, Professor Wu is in here. You don't need to go around every building, right? In order to just go to my room, you go directly to my room. Make sense? So the cloud optimized GeoTiff, you can think about at the beginning of the file, there's some notice tell you where to get to that block. So this is why it's so fast that if you need to read the file, I don't need to read the entire content. So when you're doing the streaming later, I'm going to show you is that you can get into that particular block. There's a shortcut to get to that without having to traverse the entire file. And this is why it's so fast. So you need to understand the concept about cloud optimized GeoTiff that allows you to do streaming very, very fast. So this is why we can read the data just within a second or two. So now if I run this one, the name, you see it's changed, the mode, the spatial resolution, you see it's so quick. And the coordinate system, the spatial resolution, the 30 meter, right? The width, the height, bounding box. So you can get all the metadata information, just like you open it in desktop.js. You can look at the data type. So this one is called floating because it is 7 spectral bands. So each one is using float 32. That means it's decimal point data ranging from basically whatever negative number to whatever positive number that you want. And then the transformation, something like that. And of course, if you're trying to plot the data, then it becomes a little bit slower. Right now, we're just getting all the basic metadata, so it's only tiny. But if you're trying to do the plotting, if you try to run this one, it's probably going to take some time because you still need to download a relatively large amount of data, even not like the entire amount, but it's still decent. So this is why you need to be careful if you're trying to, just like, oh, I'm watching this Netflix movie, I like it. I liked, what's the movie right now on theater right now? Oh, Snow White, okay. I like the Snow White movie. I like to keep a copy. It's high definition, 1080p. Good luck. It's going to take you some time to download the movie, right? So this part, I'm not going to show you here. I'm going to skip. It might be faster, but it's definitely going to take some time because you need to download those pixels. So I'm going to revert back to the previous one that I have, or it can be a smaller one. For example, the one that I put earlier initially. So this one is only maybe 17 megabyte, right? DM90. So it's only 17 megabyte. It's not too bad. Our internet is okay. So I'm going to run this one, and then I'm going to skip directly to this file here just to show you how to plot. So we're going to use the raster.io.plot.show, and then here you do not directly pass the URL, okay? This is the dataset reader that has been read by Raster.io. So Raster.io already know what it is inside. Then you can do the plotting. And this one is going to take a couple seconds because it needs to download the data. But take a look. Now we have this. Similar to what we have in here, right? Desktop.js. The only thing that the color is different. So you're welcome to change, for example, the symbology to something else. Symbology here, and then you can switch to a different color if you want to. But for now, I'm just going to go back to this one here. By default, it's using this color. You can change it to something else, or you can just plot a specific band. Because right now for this DM, it only has one band. So it doesn't really matter. You're going to get the same result. But the idea that you can specify what spectral band you want to plot. And you can also customize the plot. You can have a title, you can have a color map, so that you're not using the default one. But if you want to do that, then you will need to create a plot and then plot this one on the canvas and then display it. So either way, it's fine. It's up to you. Again, this one is more customizable. But if you just want to show it, you can just do one line code. So what we need to do, how do you deal with the raster? So just import raster IO and then raster IO.open. That's it. And then you get this pointer. Then you can just use raster IO.plot.show to show the data that you already opened. So basically, just how many lines of code? 1, 2, 3 lines of code. So you can create a map, show the data directly. If you want more customization, it's recommended to use this way. Okay, create using matplotlib, and I'm going to show you, for example, the 8 by 8, and then just show this one. You can change the C map, basically the color map. You can have a title, and then I'm going to show you in here. If this is not something you like, you can change it to whatever matplotlib color map available. So, for example, here, matplotlib color maps. Okay, you're welcome to Google it, and here you're going to find all kinds of color maps available. So you can choose any of those names that are available. By default, if you don't specify in Raster IO, is using this one, VIRIDIS. Okay, but we can change it to something else. For example, magma, or gray or purple or whatever. But for us, there's a particular one, for example, called terrain, flag, GIS, rainbow, blah, blah. So you can use any of those names. So for me, for example, rainbow, and run it. See, now I have the rainbow. We can have jet. So you can use any color map you like. Very simple and easy to use. And if you really want, you can plot some additional layer on top of that. So for example, I can open a vector data, and then similar to what we have earlier, you can use the gdf.plot, raster.io.plot. So think about here, the first line is to create a canvas, and then you can plot multiple data layer. Kind of like in desktop GIS, you create a map and then inject different data layer on top of that. So you can do the same thing using Raster.io like this. And take a look. So now we have this layer. We also have a bounding box, right, on top of that. So it's coming from a vector data set like this. So you can combine layers from multiple sources, either from raster data or from vector data. And you can also create a custom color bar, something like this. So right now, you can have the nice color bar on the right side here showing you. So basically, this plt.color bar, give a label. So the label would be here, the one on the right, and then shrink a little bit. Otherwise, it's really, really big. By default, the value is 1. So I'm going to show you here. If you don't shrink a little, it looks like this. So the color bar looks pretty big. So it's not, doesn't look very good. So you can basically scale it down just to 50%. Then you can have this. Questions? It's pretty simple. So this is how you can read the data, read some metadata, and then plot it using Raster.io or Matplotlib. And after that, you can do some manipulation. For example, right now I'm opening a much larger file. So this one is a Landsat data, 90 meter resolution. It comes from also my sample data set here. So I believe it's this one, 119 megabyte. It's still pretty decent size. But as you can see, 1 second you read the data, and you can see the metadata. So this one has count 7. That means it has 7 spectral bands. And I saw you the example here. It's a surface reflectance from band 1 all the way to band 7. If you're dealing with satellite data, this is something very common. You can be dealing with Landsat data, Sentinel-2 data, or USDA area imagery. You can use Raster.io to read pretty much any geospatial imagery. And you can see the projection, all those kind of information. And so in order to visualize that, we can use Raster.io.plot.show, right? So this time, take a look here, src number of band 5. So which band it is? Near infrared, right? Band 5. So here. So you can select which band you want to visualize, and you can choose a color map. So by default, this is what we're going to get. So right now is actually go to the internet to download the data and then to prepare the data for plotting. You will see this one is significantly slower because that file is 119 megabyte. But I mean, it still works. It's not downloading all the data because we only need one spectral band. We don't need the entire 7 bands. So this is just the grayscale near infrared spectral band. But if you need to visualize multiple bands all together in the same plot, you can do it like this. So I want to create a plot, a canvas with 3 rows and 2 columns. So that means we have a total of 6, right? So you can plot all the bands all together. Looks like this individually. So you can see it comes from very dark to a little bit bright in the short wave and also near infrared, because in the short wavelengths, you don't really have a whole lot of reflectance coming back to the sensor. So it's kind of appear a little bit dark. And for the near infrared, you have high reflectance, especially for vegetation and some of the non-vegetated area, you're going to have like very bright color. So you can compare multiple spectral bands together on the same canvas. This looks a little bit more complicated, but again, the idea is that you have this data, and then it has 7 bands. Okay, give me 6 bands, and then put it all together using a loop, something like this. So you're welcome to adapt the example. Or if you want to plot them using, for example, stack them together so you can have a color map, then you need to read individual bands. Okay, I'm going to read the near infrared band, read the red band, the green band, then use the MPDS stack, D stack, so multi-dimensional stack. And then you're going to put near infrared, red, green together. And then the clip means I'm going to clip the data to 0 and 1, because when you're doing the visualization, Matplotlib can only handle 0 and 1. And after that, so we also have the color map. Looks like right now, see here, it's a little bit dark because of the value range, but you can clearly see now this is near infrared, right? Plus red and green. So this is forced color composite. It's different from the previous one. We only have one band, right? Just grayscale. So this is something you can do if you want to. If you can also clip to a low data. For example, I can do like 0.2 and then maybe 0.8. So that means anything beneath that is going to change to maybe no data. Oh, not so good. So probably let me change this one back to 0. And I maybe change this one to a little bit lower, maybe 0.6. It's a little bit brighter, but it's not super good. So maybe 0.4. A little bit better. So then 0.4 basically is just the reflectance. So anything greater than 0.4 is going to become brighter color. And after that, you can do some simple raster calculation, also called the mathematical equation. So for example, if you need to calculate the NDVI, because after you read the near infrared band, right? NDVI is near infrared minus red divided by near infrared plus red. And then you can do the scaling here. Everything else remain the same. So this one will be calculating the normalized difference vegetation index. Have you calculated the NDVI before using desktop GIS? So if you're using desktop GIS, you need to select the band and then use, for example, ArcGIS raster calculator to calculate. But you can do that just with a couple lines of code using Python, using Rasterio. So it's pretty simple. All you need is just this equation, kind of like the mathematical equation. So it's based on NumPy. So that's why you can do that pretty easily. And lastly, you can save the data. So if you did like, okay, I have do some calculation. Now I want to save the data. Using Raster.io and GDAO to save the data is a little bit tricky, because when you are saving the data, you need to make sure that you have the metadata. So as I mentioned earlier, if you have a GeoTIFF, if you want to open, there's some metadata information at the beginning. They store the information, the structure of the data. If without it, it's non-geospatial data. So a TIFF, it can be a geospatial data. It also can be a regular TIFF without any geospatial information, right? So if there's no geospatial information, it's not a geospatial data set. And this is the one that's super important. So you can, once you open the data, you can look at the profile. So keep that in mind. Earlier, this is the Lancet data, right? And if you want to save the NDVI, the same extent, same resolution, everything the same as the original data set, except, so how many bands is the NDVI? How many bands for the NDVI imagery? Oh, you can use near infrared and grid to calculate it. But what's the result? What's the NDVI result? How many bands? Just one, right? So think about here. You have 7 bands, or maybe 2 of those, and then if the outcome is just 1 band. But if you need to save the result, you need to make sure that they align with each other, right? So all the metadata information here, it should be exactly the same, except this one, the count. So instead, because you know to keep the spatial resolution, the georeference, everything. So this is the same profile, except that we're going to update this one from count 7 to 1. And that's it. And then we need to use this piece of information to save into the data so that the imagery will align with each other. Otherwise, you're going to have problem because they don't align with each other. So this is what this one is doing. Profile, update, and then the data type, we're going to change it to float 32. The count is number 1, and also the compression, LGW, or deflate, or any other compression you want. So what we want is, okay, this is the piece of metadata that we need when we save the data. And this is it. So look at this one. Output, okay, we're going to save the NDVI. And so when you open the data set, you can open it in the read mode. Compared to the one earlier, we're just passing the file path. If you don't specify the mode by default, it's going to be read, okay, read only. But you can also create a new file. So W means going to write. This is similar to the open a file, right? Earlier this semester, we talked about how to open a file to write some text into the file, right? Remember, open, and then you're going to have the W mode. So it's the same idea here. But the only thing that's different here is that right now we need to pass in a profile, tell Raster how you want to save the data, what kind of metadata information. And this one is a little bit tricky here. You have 2 star. That means you're going to unwrap the dictionary into something. Basically, it's like, okay, count equal to 1, CIS equal to something, blah, blah. So rather than writing the dictionary out, we're just using the profile, double star. That means you're going to unwrap the dictionary for you. Make sense? Otherwise, you're going to write a long line of parameters. So with this, you open the data, and then you specify all the meta information. Now you can write the data, and then the data you have, and which bank you want to write into. Because right now we only have 1 bank, so we only have something like this. Execute this, done. So now I have the data saved as ndvi.tif. And so if you go to where you save the file, where is it? 510. Book geospatial here. Modify. Okay. Now this is the NDVI. So I'm going to drag this one to here. And then look at this. So this is one that has been saved to my computer. Although right now it doesn't look good because of the stretch. But do you see that it aligns with the base map? Yes. And that's all you need for this one. Without this one, the map has no geospatial information. You don't know where it is. You have no idea. Let's try this one, right? If I remove it, see what happens. I'm going to open this new file and then W mode and then just write to it. See if it works or not. It even doesn't allow you to do that. So integer width and height are required. And even though you can just provide this one. So for example, I can say width equal to, what's the width? 2485, right? And then height 2563. Let's see if it works or not. may not. Okay, and there's a lot of things you need to provide. Okay, bank count. That means I need to provide bank count. Okay, count equal to 1. A valid data type is required, right? You can keep going on and on. I hope this is the last one that's needed. Okay, D type equal to float 32. If it works or not. Okay, now it works. It's fine. But no geo reference warning. Data set has no geo transform, GPC, blah, blah, blah. And so if you want, let's open this one. See where is it right now. This is the global map, okay? And I'm going to drag this file into it. You can see the file size right now is a little bit different. But where is it? Zoom to this. It's in the ocean, probably somewhere. Or not, even not in the ocean. Because then right now there's no geo information. It doesn't align with a data. It's here. It's in the ocean. It's 0, 0, somewhere here. Not 0. Is it 0? Anyway, it's definitely something wrong, right? So it's near the center of the map. And this is not exact. This is definitely not where this is supposed to be. So this is why it's super important that you make sure you know the basic information about the raster imagery. You need the profile. So the basic thing you can do is, if you're opening the imagery, you do some manipulation, and then you generate some result. But you want to save the result using program without using desktop.js. You need to make sure that this imagery keep the spatial information. So the best way is to read the profile and then update just some tiny pieces. From, for example, 7 band to 1 band, or it might be 3 band, whatever. So you update a little bit information rather than have to write a long line of this. It's not easy, okay? So for me, I'm just profile and run it. Much better. So now if I remove this one, and then drag this one again, okay? So now it aligns as expected in the location that it's supposed to be. So this is how you can do some data processing and visualize them on the desktop. You can clip the raster. I think I'm going to skip this one. You're welcome to check them out, and also with projection. This one is a little bit more complicated, but it's reproducible. So you're welcome to try these things out. It's not the focus of this section, because we're going to focus on how do we use Python to read the data and then how to visualize them. So in the next section, I'm going to go cover local tile server. So I'm going to open this one. I'm going to skip to this one right now. So that how do we visualize the imagery interactively in a Jupyter notebook? Because what I'm showing you right now, I still use a mix of Jupyter notebook and VS Code. But it would be nice to be able to just visualize everything using Jupyter notebook without having to open desktop.js. It's super nice because you might be working in an environment that don't have desktop.js. You just have the web browser, you have Google Colab, but how to actually visualize the data. So the package you're going to use is called LocalTileServer. You're welcome to Google it. LocalTileServer. So this is a nice package that allows you to visualize data interactively in a Jupyter environment. So what it's doing is basically, think about here. It spin up a server on your computer, and then the server is serving this imagery. When you're trying to visualize them, it's going to request a tile. This is why it's called local tile server, because behind the scene, it subdivides your image into smaller tiles. So when you zoom in, it's going to grab the tile just for the area. So look at this one, just like the example here. And you don't want to download just like you're watching a movie on YouTube or Netflix, right? It doesn't download the entire video all at once. It's doing the streaming. So when you zoom in and zoom out, we are requesting a certain tile for your extent at your certain zoom level. And it makes it really, really easy to use. So for example, right now, if you look at this, this one is not interactive anyway. So allows you to, for example, forget about how to spin out a server, how to do the tiling. It will do everything for you. So let me go back to the example here. And make sure you install the package. Right now, I'm not sure if it is installed or not. Let's try this one. Open this. Okay, so it's not installed yet. So this is where you may need to install the package. And so for me, I'm just going to open my terminal here, and then conda activate geo, and then mamba. Okay, install sc conda first local I server. Or you can use a pip as well. Either one should be fine. So because this one it relies on Raster IO and some other packages, it might be a little bit difficult to install on some operating systems. So it might run into errors. And this is why this one is not put in the requirements.txt file. As I mentioned in the past, if some of the dependency are difficult to install on some computer, you want to be careful about putting that in your package requirement dependency, because other people might have hard time to install it. You can make it as an optional dependency. So user can still install your package, but we only install this additional dependency when we need to use it. Otherwise, we'll be just using the basic functionality without using Raster.io. Okay, so take a look. It's going to install a bunch of other packages. You can certainly see here, it's going to install Raster.io, updated it, and then also a bunch of other packages. All we need to do is just hit enter. Then install the package. All right, so it's done. Hopefully no errors. Restart the kernel, and then import the libraries. Sometimes you run into errors, sometimes not. Okay, so we are good. So right now we're using LocalTileServer. We're going to import the Tile client and some of these functions. So next, let's think about how are we going to use it. So there are different ways you can use it. You can use it Tile client and then passing the file to your either it's local file path or it's a HTTP file. I will show you later. But you can also use this example. So here's the example: get San Francisco, and then it's basically going to use their sample data set that they have. And after that, if you show that, look at this. So now we are visualizing this imagery interactively. We zoom in. It's loading, it's spinning. So the reason for that, think about there's a server right now serving this file. The analogy will be like you are a director right now for a movie, right? For many movies, you have produced a lot of movies and you want to share with your friends or your family, and you don't have Google Drive, you don't have anything else. Right now, you need to build your own server and then send the URL to your friends so that they can access. So this is exactly what this one is about. It's spinning up a server on this computer, and then generating the tile. So when they access this imagery, depends on the zoom level. Right now, you probably see this one, right? See these lines? It's supposed to it should be seamless. There should be no vertical line. Ideal situation, you should not see this one. But right now, there's some artifacts in here. Just like IPyDiv, like using OpenStreetMap. The data that you see is vector data, but this actually right now is just JPEG, PNG, smaller pieces. So same thing, right? If I zoom in, pay attention to this one. After it's spinning, do you see the new vertical lines? Essentially behind this thing is we sampling imagery to low resolution, subdividing into pieces. And so what we're seeing is a coarse resolution data, small pieces put together, looks like seamless, but it's not. So when you zoom in and zoom out, for example, if I hover my mouse to the other portion, you will see probably it's taking some time. It's loading up. So if I zoom in, see the buffering, and now it has a high resolution. So this is essentially what cloud optimized GeoTIFF it is. It's doing allow you to do the streaming and then get the data only needed for your area of interest and also at a certain level. So this can be useful to visualize data that has many, many gigabytes. It doesn't matter. Right now, we are just doing this way. So later, I'm going to show you, for example, how do we retrieve data for other data set. So same thing here. Now we can actually look at the one that we downloaded. So for example, I have this data set downloaded the DM that we have earlier. Okay, so for example, for this one, I'm going to just copy the URL, and so you can construct a Tile client and then DM, I think 90.tiff, 90M, right? Or 90. Look at this. Oops. Is it the wrong file? DM Hi client object have no. Oh, just the type client. So this is just type. I need to update it. You can just put the client CLIENT without this one. See, so this is the one that earlier, right? We use desktop.js to open it, but now it is pretty cool, right? 2 lines of code. I can visualize the imagery interactively in Jupyter Notebook. I don't need desktop anymore. This one right now is like only 70 megabyte. How about let's try the other one? How about this my 119 megabyte? Copy the URL and replace this. Run it. It might take a little bit longer, depends on the file. So if it is not cloud optimized geotip, it's going to take a whole lot longer. But 119 is certainly faster than you trying to download the entire file to your computer. So right now you will see here, this is just basically 2 tiles, and inside the file has a pyramid. So the pyramid means this is the native resolution, for example, 90 meter, and then it's going to build up 180 meter, and then 360 meter. So the pyramid means it's cosine resolution. Think about if you have a photo, right? You zoom in, you're going to see the more pixel, but when you zoom out, you don't need all the details. So inside the file, it has those structure that allows you to request a coarse resolution. Now, if I zoom in, see, it's spinning. It's requesting the tile. So it's figuring it out which tile need to be fetched right now to see it. And look at this. Right now, you notice like earlier, you only have 1 tile, another tile. So now we have 4 tiles actually behind the scene. You zoom in again, it's requesting the tile. I mean, ideally, it should be much faster. Right now, is the package has some bugs. So it's a little bit slow right now. It used to be very fast, but I will show you another way to make it faster. But it should work, you see? It's continuous, basically, it's a hierarchy of tiles, right? From this one, and then subdivide this tile into 4 tiles, So it's basically by the times of 4, go all the way in. And this is just 90 meter. If you want, you can change this one 1.02 gigabyte. And it's certainly going to be faster than you try to download this one to a computer. You see, 1 gigabyte. I have the imagery, and it's display. You can zoom in, you can zoom out. Pretty nice. You can get a thumbnail, you integrate with iPyLeaflet. So here, let's see how we can integrate with iPyLeaflet. So for example, for this one right now, let's see if this is iPyLeaflet or Folium. But let's be more specific. So let's look at an example how to integrate this one with iPyLeaflet. And because our package is built on top of iPyLeaflet, so now we can actually do this one using, for example, something like this. So this is just one imagery, but again, we can just hi client and then parentheses. So assume that we have some data. Probably I'm going to use the one for my local computer, but I can use anything from the internet as well. And then dm 90m.tif. But you need to the client type was the somewhere here, actually here. So you see, I was able to visualize, and I don't really like the opacity. You can also add a color map. So CMap, go to terrain. Here. See that? So using this couple lines of code, now we can add the layer to the map, and we can visualize them directly on the map without having to worrying about the server. So the whole idea is that if you want to integrate this one to your package so that you can visualize some data, just like what we did previously using egg vector. How about now we add a function called add raster, and then just give me a 5 pass, everything else will be taken care of. Can we do that? Know how? Like we have the working example like this. All you need is copy and paste and then put it into your map, into a function. It should be done, right? All you need to do, pretty much, will be m equal to map blah blah something. I don't even need to specify the center and the zoom anymore. And then on this one, now we're creating a new map. So all you need to do is figure out this. And so for the client, you should have a center. Let me 1 second here. Zoom, and then client dot center. So it actually has a center that allows you to name it to parentheses. Right. So you can actually automatically zoom to the center of the map. Right. So what you need to do here, you'll be m dot center equal to client dot center. So in this way, you create the map, you add the image to the map, and then automatically zoom to the layer. Okay, right now it zoom directly to here, and then you can set a zoom level. For example, m dot zoom equal to maybe 6, whatever zoom level that you like. Okay. Same thing like what we did previously using the vector data, right? Add vector and then just zoom to that. We have 2 minutes, but now let me just quickly show you how we can done in 2 minutes to add that to the map. So add the functionality to the map. So I'm going to go here and then open the software package, right? So from here, I'm going to go to GeoDV and then under the GeoDV, right? So this is essentially what you need to do is to create a new function, for example, df, and then add parentheses, and other that, just paste the information back in here. Oops. So I don't need the map. I can just indent it. And we don't need the map. We don't need this. And so all we need to do here will be just from LocalTileServer import client. That should be pretty much it. And also get local tile layer. Then this 5 pass is the one going to be from your data, from your parameter. So I can see here, for example, file name or maybe file path, and that's it. And then I'm passing all the parameters to the function. So I need to just replace this one with here. And then everything else will be star, something like this. And then should be it. Make sense? Oh, no, see, good point. It needs to be self. Oh, this is wrong. You need to put a self at the beginning first. Okay. And then from this one, it changed m to self. Or it can be tweaked like this. Oops. And self. Self. We improve it next time, but for now, I just want to show you this is essentially what you need to do is to add this one to your package. So now your package can visualize raster data just like this. So once 1 minute, let me show you, see if it works or not. I hope it does. If not, then we'll continue next time. So for example, go to examples and then maybe create a new new notebook. Oh no, it's wrong position. I'm gonna go to the examples. Oops. New file and maybe raster.ipynb. Okay, and then from here you'll be import geodev. Okay, and after that, do this one m equal to g. Good. Okay. Oh, okay. Then let's try again. Put GeoDV, return, and then it will be GeoDV dot map, right? And can display the map. That's it. So now I can have the raster file name. It can be a local file path or it can be a file path from the internet. So I'm going to use the same one that we use here. Now I don't need to worry about the type client because under the hood we handle that. So, oops, where is it? Here, this one, and then you'll be just m.add raster. Nice file name, and I can pass in any parameter I like directly into the function. So terrain alpha equal to 5, maybe 1. I don't know alpha, just the color map. So, oops, missing one. One last one. Come on. Hopefully it works. Oops. The color map is no argument, so let's ignore this one for now. If there's something wrong, we'll fix it next time. I just want to show the imagery. And is it coming up? Okay, something wrong. We'll fix it next time. I don't want to drag for too long. But this is the whole idea of like getting an example done and then slowly integrate the functionality into your package. Okay, see you next